Now, normally, this cutting bit, and a person would think there is a given a rotation to it. We're going to try it backwards today for a little bit, just because it's part of what we're doing today. We're talking about whether there really is a given direction to tooling, or whether it's just in our mind. So we're going to run this backwards. We're going to run it slow so you can watch if any pieces chip off or anything. And actually, it's doing very well. So I've had many times that doing a procedure like that just totally broke things up, but as it turned out today, it did not. Oh, it did. It did. I thought it would break it a little bit, but yeah, it did. You can see that it broke it on the top. So maybe going backwards did some damage to the tool, but it was still cutting quite good in reverse. Now let's see how good it cuts in the not reverse. So I have got to switch this to make it turn the other way again. And we'll leave it slow yet. Definitely cuts a little different, but it still cuts both ways. Yeah, I didn't see the chip at first. I kind of thought it was going to do that, which was going to be my point to show everybody, both that it chipped it and that it would still cut. We're going to do another one, and we will again reverse that. And after taking forward cuts, look and see if there's any other change to the bit that matters. May have burnished it out a little bit. But we're going to, for reference, because we know that if we always were turning it in the normal direction, it would be unlikely that we'd have such damage. But it's also, some tools will damage less than others, like this high-speed steel and this relatively soft steel here. Let me give it the same depth, because I did actually have a depth of cut. I did not just come in here and just have it rubbing, or in quotes, no pressure. So we're going to try this again. Let us look at the bit. We didn't take a big piece off of the top. We made a lot more of a flat on the front than what we had with the carbide, because the high-speed steel wears more. And then again, we will go in a forward direction. And see what we get for cut going forward. Lots of ways to remove metal, and there's some reasons why sometimes you want to go backwards or have to go backwards with a tool. Generally, I like going in the direction that the geometry prefers. It's a more definitely going to work. You know, I'm not going to say that just because we run something backwards. I was amazed at how well the carbide only just chipped a little bit. I thought it was going to break up a big old piece. I figured it would still cut, but I thought it was going to break up more. And you can't guarantee when something's going to be bad. But doing procedures that makes things not bad is generally better. Now, well, I say generally. Now, let's look at something over here. Or actually a few things as we're going around. Start out with real basic. We have a hacksaw, we have a sawzall. And the hacksaw, you can get a lot of life out of the hacksaw by sawing forward and yes, picking up, coming back and doing that again so that you don't wear the blades out much. A sawzall, it's not practical. It's going too fast. You're not going to be able to pull back, pick up. You're not going to be able to do that. And so you have the wearing on the back of the teeth. And you won't remove as much metal per blade, but it's so much easier. So we do it. I mean, we don't complain about it. We just do it. We use the things. We don't say that that's an excuse for getting less life out of our hacksaw blades or other things, but we do let it drag backwards. It just makes sense as a thing to do. I had a saw that I spent a little extra for. It was made by Bosch, and it had a eccentric pattern to it. It was a jigsaw. And when using it on steel, you would notice that it cut okay, but the steel would bounce around more because of the steel not having anything consistent to it. So the control wasn't quite there. It was great on wood. It would just really rip through wood, clear out the chips real good, and you would think that the steel would be the more important one. Eventually, a little eccentric mechanism broke. I haven't bothered to spend the extra $200 to buy another one like it. I liked it, but probably wasn't really worth the fight. But that's an example of going both directions. It's fine. We have one over here. And it's always fine if it works for your point, you know? It's just, if you want to do it as your habit, that's fine. I just think it's better to try and make the best life out of the tools. One that is common to do on a radial arm drill or a lot of drill work where you're picking stuff up, you'll turn your drill bit backwards and you'll pick up on a hole. And by turning it backwards, what that does, it keeps it from cutting the hole. If it starts out cutting the hole on one side, then eventually when you pick up on that hole, you're going to be closer to that side because some of the top of the hole is already gone as soon as you touch it. So that's why you run it backwards. Most of the time, mild steel, you don't have problems. But I've had some times doing that where with 4140, T1, different steels, I've had times where it's worn a groove right in the end of the drill bit where I was doing that. Now, sometimes it wears a groove in here while I'm going backwards and I go ahead and use the drill bit, it drills, it mushes a little bit at the edge, it doesn't matter that much. Other times I go, oh shoot, I gotta go sharpen it. So I can't guarantee it's gonna wreck the drill bit by turning it backwards, and it's a really handy trick. You know, turning it backwards, picking up the hole, letting it actually move the radial arm. We probably should do one where we actually do that sometime with the radial arm turned on and everything, but not quite set up to do that handy right now. We have another one back here on our slaughter. So our slaughter that we use quite a bit, it goes back and forth also. Here's one of our other tools we've had for it. If it was a shaper, what a shaper has is you go forward, and then when you go to drag backwards, it hinges. So it makes sure that there's no pressure and even picks up a little bit on. Some of them actually have a device that actually picks the tool up a little bit. In fact, we built one with a hydraulic lift and push down both to make sure that it was absolutely secure so that we could do no dragging on some carbide tooling we were using on another machine. But what you find with that is that hinge is not very secure. So your tool ends up wobbling a little bit side by side and you don't get a good cut because of that. The same thing that normally would aid you in making sure that you're not tearing up your bit by dragging it backwards hurts you because of the hinge effect. So on this slaughter and on a lot of times when you're doing inside work with shapers, you'll just lock the clapper. It's called a clapper because it goes clap, clap when it's working and hinging. You'll just lock it out. There's a set screw here, you tighten it down and it doesn't move. And so that's what you do with this a lot of times. So now that we have it locked out, what you're going to do is you're going to go forward and you're going to drag back a little bit. Now, part of that going forward and dragging back, you have the shape of the tooth. The tooth is flat in the top. If we had a very strong positive where it was cut out here and there wasn't much reinforcement, when we drug back, it would want to break it off more. So you do normally try and grind your tools a little bit to match the fact that you might need to run it in an opposite direction from its normal cut. So another thing, which we're going to go up to the board, but another thing that people talk about this, I've never used one, but a die filer. Die filer is a machine that goes up and down, up and down, up and down, or this way. I don't really know. I've never used one. I've seen pictures of them. When I first saw one, I thought, well, that's kind of a goofy thing. It's just always going both ways. But guys in the tool and die field that have used them in the past before they had good, accurate CNCs to mill out most of those pockets, I imagine they still probably use them some today. The guys that are doing that could let me know in the comments, because I really don't know. I know the CNC would make its use not quite as needed as it used to be, but that's another tool. What we're going to do is we're going to go look at the geometry of a file, because that's kind of where all of this forward and backward started from, and you probably already guessed that because we've been talking about files lately. Pretty sharp little teeth on this one. And I'm going to draw them down, kind of like that. Let's see if we get a second one in here. Okay. So we have these little teeth like this. You go forward, the chip cuts up, makes a little curl in here. If you back up, let them go out, they're out of your way, not tearing anything up. But if you needed to, if you drag backwards, these may or may not hurt the tooth. A tooth that was a little bit straighter, not quite as bitey, a tooth that had a little bit more behind it would be more durable. If we were really going to make a file for, let's say we're going to make a file and we really want to have it set up so that we can go both directions without causing too much trouble. Yeah, that's a little too not strong enough. Let's go like that. Then we could actually design a file that was made. It was pretty much made for a little bit of a cup. Still making that too where it's not strong enough. So we could make a file, and I'm sure with a little trial and error we could come up with a better shape. But just generally, we could come up with a file that's meant for both directions. Now, it's not going to cut as good as this one in the forward direction no matter what we do. It's going to be a file, going to be able to cut both directions, but I don't really see it as being a great thing for industry. Now, on the other hand of this, while I was thinking about all this, we could do another thing too. We could do one that is, that is like this. That's, and we just have a bump here and a bump there. Then we have a file that won't file in either direction. So for some people, that would be the epitome of files. It would be absolutely perfect. Other people might like that one. I kind of like the old school files.